The next step with scientific notation is to use it with all the four operations, so multiplication, division, addition, and subtraction. With these numbers, we could expand them into standard form to make the numbers. For example, 2 times by 10 to the power of 2 is actually 200, this first number. And we could expand the second number as well. There is a shorter way that we can keep it in scientific notation and multiply them together. So let's have a look at that. First thing is to take the first part of the scientific notation and to multiply those two together. So 2.0 times by 3.0. Then we take the bases with the powers and we multiply those together. So 10 to the power of 2 times 10 to the power of 6. And they'll both be multiplied together. Now to finalize the equation, let's multiply the 2 times the 3 on the left-hand side of the equation, giving us 6 times by, we need to go back to indices or our knowledge of index when we've got the same base. What do we do with the powers? We add the powers together. So the base will stay the same. It'll still be a base of 10, but it'll be to the power of 2 plus 6, which is going to be to the power of 8. So our answer is 6 times by 10 to the power of 8. We can see that that answer is perfect because it's still in scientific notation because this number is between 1 and 10 and it is a base of 10 with a power. Let's do the same with our second example now. So remember the first step is to combine the first part. So it's going to be equal to 4 times 3. And then the same with the second parts. So 10 to the power of negative 2 times 10 to the power of 6. Multiplying both those together. So in this case, 4 times 3 is equal to 12 times by, remember when we've got the same base, we add the powers together. So negative 2 plus 6 is equal to 10 to the power of positive 4. Now this isn't correct in scientific notation because you can see our first number is not between 1 and 10. So what we are going to have to do is, therefore, move the decimal point. The shortcut in this case is what you could do is, knowing your understanding of scientific notation, you should know the decimal point is after the 2 digit, and you could move it one spot further across. It might get tricky. I now know that that becomes 1.2 times by 10 to the power of 5. I've moved it one more spot across, knowing this is a large number, so I know that I'd have to add 1 to my power. Let me explain why. Essentially what I've done is I've turned this number and split it up into 2 different values. So I've used it, and I'll do it over here for you. 12 I've made into a scientific notation number by going 1.2 times by 10 to the power of 1. So you can see if I was to actually do 10 to the power of 1, I'd move it there, it would be 12. And then I've got the other part, so that's the 12 part. So you can see that I've actually just crossed off the 12 part. Then I've got times by 10 to the power of 4. So this times by 10 to the power of 4. So using the same theory that we did before, we are left with the 1.2, which ends up down here, times by, let me highlight it, 10 to the power of 1 times 10 to the power of 4. So these indices here, therefore add, and that makes our 10 to the power of 5. The same theory then applies to dividing with scientific notation. So first we are going to take the first coefficients. So it's going to be 9 divided by 2. The times by will stay the same. And then 10 to the power of 8 divided by 10 to the power of 2. Now let's complete our next step of the operations. So 9 divided by 2 is 4.5 or 4.5. The times by stays the same. Now with what we know about indices, same base, when we're dividing, we subtract the powers. So 10 to the power of 8 divided by 10 to the power of 2 becomes 10 to the power of 8 take away 2, which means it's going to be equal to 4.5 times by 10 to the power of 6. Let's look at this final example. So same thing applies with these two really small numbers. So the coefficients will have 4 divided by 8. The times by symbol will stay the same. We'll be multiplying it to the power of 10 to the power of negative 2 divided by 10 to the power of negative 6. So we then go to work that out in our final step, and I'll change my colour quickly. 4 divided by 8 is equal to a half. It's 0.5 times by, be careful with our negative numbers, so the same base. So we're going to, when we've got the same base and we're dividing, we are going to subtract the power. So negative 2 take negative 6, that's going to be the same as negative 2 plus 6. So it's going to be times 10 to the power of 4. Then you'll notice that this isn't in scientific notation. So what I like to think about is that 0.5 is the same as 5 times by 10 to the power of negative 1. It's a small number. We would have moved the decimal point 1 to the left or in the negative direction. And then with this one, times by 10 to the power of 4. If we use the same theory as we used before, our answer is going to be equal to 5, so that's our coefficient. And then let's put these two same base powers together. We're multiplying them, so we're going to add the indices. So negative 1 plus 4 is going to be equal to 3. So our answer is going to be equal to 5 times by 10 to the power of 3. The important things to take are, remember that the coefficients, you can multiply or divide them together. And then just remember your rules with indices, and also remember that your answer, to be in scientific form, the coefficient must be between 1 and 10. Be careful when you are trying to switch a coefficient that wasn't between 1 and 10, whether you need to possibly add or subtract some powers in the base.